Okay, before we start, can I please get confirmation that you guys can hear me and see my screen as well? Okay, perfect. Okay, let's begin. Assalamu alaikum and good morning, everyone. Welcome back to grade 11 Maths by Inspired Teens, where in today's lesson we're going to be continuing with trigonometry. Okay, cool. So yeah, just remember, guys, if you guys do have any questions, please ask them in the chat or in the Q&A on YouTube chat if that's where you're watching. And yeah, the notes will be sent to you guys afterwards, and the notes can be accessible from a Google Drive. The link for that Google Drive is in the group description. Okay, so last week we started trigonometry, where we did like hypotenuse, basics of sine and that, and then we did basic of cast diagram, Cartesian plane, and then we moved on to reduction questions. Okay, and we did some reduction questions. We learned about co-functions. Did we learn about co-functions? Yeah, we did. And yeah, we did negative angles. We did, I think, all the examples for reductions. And this week I said, I'm pretty sure I told you guys we'll start off with some reduction questions and then move on. Yeah, we also did reciprocals. We did special angles. Okay, so we need to finish the special angle questions and then we'll move on to Cartesian planes. So let's have a look at this, right? We're going to solve it in a bit. Just give me 1 second. Let me. Okay, actually, I want you guys to attempt it. Okay, so I'm going to give you guys 3 minutes. Okay, so at 11:05 or so, we'll do it together. So I want you guys to attempt it. Take out a pen or paper and attempt this question. Okay, and yeah, we'll take it from there. We'll do it when you guys are done. We'll go through it. Yeah, I'll give you guys a few more seconds. Okay, let's solve it together, right? So yes, we learned reduction. So let's have a look. So first question is tangent 180 minus x. Okay, so that's fine. Right, remember, you draw your little cast diagram to decide whether your trigonometric co-function is positive or negative in that respective quadrant. So 180 minus, actually, remember 180 is here, less than is minus, after it is positive. So 180 minus is in the second quadrant. In the second quadrant, only sine is positive. So that means that tangent is definitely negative. So it becomes negative tangent x times cos 360 plus x. Now remember 360 plus is in which quadrant? 360 is here. Before it is minus, after it is plus. So 360 plus is actually like in the first quadrant. Oh, we forgot to do one thing, but we'll do it later. Okay, 360 plus is actually in the first quadrant. In the first quadrant, all are positive. So since all are positive, cos is also positive. So it changes, it simplifies to cos x, positive cos x. Okay, then we talk about 2 cos, so don't worry about the 2, you just leave it as a 2 in front. Okay, cos 90 plus x. So the first thing you should notice is that you're dealing with cos and 90. What happens when you deal with cos and 90? It's going to change, right? It's going to change from cos to sine. So that's the first thing. So cos and 90 plus, that helps us to determine the sine, remember? So 90 plus, right? 90 is here. After it is plus, before it is minus. So 90 plus is in the second quadrant. In the second quadrant, cos is negative. So it's going to become negative. So we're going to have negative 2. So you can just write the 2 as is. So negative 2. Okay. Then where did we get the negative from? Negative 1. Remember, where did we get this negative from? This negative came from the fact that it's cos 90 plus. Cos 90 plus is in the second quadrant where only sine is positive, so cos is negative. However, we're not going to write cos. We are going to write sine because when we're dealing with because when we're dealing with 90 and cos, we change to sine. So it becomes negative 2 sine x. Okay, so now how do we simplify it further? Okay, this we haven't really done. We haven't really done identities yet, but I suspect that most of you do know that tangent is equal to sine of cos. If you don't, it's okay. We will be doing identities soon enough. Okay, so negative tan changes to actually negative tangent. Tangent can be written as, here we go through that at some point. I don't think so at all. It's only in identities. But what you should know is that tangent x or tangent anything can be written as sine x over cos x. Okay, so this can be written as negative sine x over cos x times cos x all over negative 2 times sine x. Okay, so now this is where the simplification begins. We have a fraction here multiplied by cos x. Okay, so remember cos x can be written as cos x over 1. So we have multiplication of fractions. Remember in multiplication of fractions, you can always cancel if two things are the same in a numerator and a denominator, top and bottom. Okay, so that's exactly what we're going to do. So now if we simplify, we have negative sine x on top essentially over negative 2 sine x. So actually the negative and negative also cancel. And we can also cancel sine x and sine x. So remember on top, you're actually not left with 0 or nothing. When you cancel this, you are essentially saying negative 1 divided by negative 1, and that actually gives you 1. When you cancel this, you're actually saying sine x divided by sine x, and that gives you 1. So you're left with 1 times 1, which is essentially 1. You're left with 1 on the top and 2 at the bottom, so it's a half. Okay, so for those of you who didn't get the tangent thing, either you haven't done it in class yet or you're not so 100% with it, but don't stress if you didn't get the tangent part. Okay, then quickly, this one should be okay. Okay, no. Before we continue with this one, we just need to discuss one more thing is angles larger than 360. Okay, so this is a simple concept. What happens, okay, if you have something like sine 720 minus x? Okay, so now this is none of our reduction angles. Okay, but it's simple because whenever you have angles larger than 360, all you do is subtract 360. Okay, you subtract 360 in multiples. So you can either subtract 360. However, if it's bigger than double 360 is 720, you will have to subtract 720. And if it's bigger than triple of 360, which is 9, what is it? 980. 980? I'm the math teacher. 1080, yeah. 1080. Okay, then you would subtract that, but generally you don't really go up to that, so it's fine. 720 is normally what you go up to. So in this case, this is not bigger than 720, so we simply just subtract 360. You don't even have to show the step. You're just gonna minus 360. Okay, and write it as sine 720 minus, 720 minus 360 is actually 360. And then now this you can reduce. 360 minus is where cos is positive, so this is negative sine. Let's do another example. Let's do, what if I have cos cos 540 plus x. Okay, in this case it's bigger than 360, so what do I do? Minus, actually no, let's do this. What happens if I have sine 8110 plus x? So in this case, it's actually bigger than 720 even, so I minus 720. So it's like you minus 360 minus 360 again. Because you see, when you minus 360, right, you're gonna get another number that's bigger than 360, so you're gonna have to minus it again. So minus 360 minus 360 basically. And then this gives you cosine. Again, like I said, you don't even have to show the step, you can go straight from there to there. 90 plus x. Okay, cos. When you see cos and 90, you think, okay, it's going to change to sine, but I need to determine my numerical sign first. If I look at cosine 90 plus is actually in the second quadrant where cosine is negative. So I'll put a negative down, but it becomes sine because of the cos and 90, the negative sine x. Okay, so that's how we do it. Now I want you guys to attempt this one quickly. Don't worry about 6.3.2, just 6.3.1, just to simplify the expression. Yeah, just simplify the expression. So I want you guys to try this one. I'll give you a little bit longer for this one. So let's say 6 minutes at 11:20 we'll mark. Okay, so give this one a go. Okay, I don't know if I maybe allocated a bit too much time for that, but let us mark. It's almost 11:20. There we go. Okay, let's do it together. So we have, okay, we start off with this guy, cos 180 minus x. We have our little cast diagram. 180 minus is actually in the second quadrant where cos is negative. Okay, so cos is negative, so it becomes negative cos k is our angle this time. Okay, then we have sine k minus 90. Now that's an issue. Why is that an issue? That's an issue because we cannot have a negative reduction angle. Okay, so we have to change it. If you remember how we change it, the shortcut is to just write it as negative sine and then flip whatever's inside, 90 minus k. So negative sine 90 minus k. Okay, remember why do we do that? Because like we take a negative bracket, sine negative k minus 90. Okay, so then, oh, sorry. When you take the negative bracket, it changes. It becomes like negative k plus 90, which can be rearranged to sine negative 90 minus k, still the same value, because if you multiply out this negative, you're still going to get what you previously once had. And this is like having a negative sign. You take it outside, it becomes negative sine 90 minus k. Okay, alternatively, you just take the shortcut to that. No, sorry, this one. And you're not going to lose any marks. Okay. So that simplifies to that. Okay, then we can reduce it on the next line. That's fine. And we actually have minus 1. So just minus 1. Okay, just be careful with the minus 1, right? Because now that's minus 1. It's not multiplication. Okay, so we have to just be very careful there. Then at the bottom, we have 10 squared. We didn't do squared, did we? I knew we had some deductions to do, but it's fine. We'll do them now. Okay, so let's just learn it here. Okay, so firstly, 10 squared, before we simplify, tangent squared, the 540, I need to convert it. I need to subtract 360. That's what I'm going to say 540 minus 360. And that's going to give me 180. So I need to re-express this as 180 plus k times sine 90 plus k. Then cast diagram, 90 is there, plus is where sine is positive. So this then simplifies to positive sine k. Okay, it simplifies to positive sine k. Now, cos negative angle, remember cos swallows the negative, so this is the same, cos negative k is the same as writing positive cos k. Okay, so we simplified as much as we could on one line. And actually, I noticed that here is negative cos k and here is negative cos k. Can I cancel those? Yes or no? Tell me in the chat. Ah, yes, correct. Very good. Correct. I see that immediately. You are correct. Here, this is supposed to change to cos. Okay, it's easy to forget. So that's why you should always notice it immediately. Sine and 90. It changes to cos. And yeah. Can I cancel this cos and that cos? Yes or no? Yes or no? Yes. No, the answer is not yes. The answer is no. The reason for that is because of this minus. Okay, let's simplify this in terms of variables. It's like I have a times b minus 1 divided by, let's just say, c times a times a. Now, it might look like I can cancel a and a, but that is incorrect because I'm canceling across a negative sign. That can never happen. Okay, it needs to be only multiplication. This is not times negative 1. No, this is just minus 1. So I did the cos 180 minus k become negative cos. Okay, I'll explain that now. So you cannot, if as long as there's a plus and a minus or a minus, you cannot just cancel. If I have A times B times 1, that's a different story. Yes, yeah, then I can cancel, no problem. But because of this negative, I cannot cancel. Okay. If I had, for example, A times A minus B over C times A minus B, now I can cancel when there's a negative. But you see this, in this case, I'm canceling out the whole thing with the negative. So if you're going to cancel, you're going to have to be able to cancel with the negative, everything. And I can't do that because it's not common on top and at the bottom. So this minus is preventing us from canceling that and that, okay? Because I have to cancel everything then, okay? Someone's asking, how did I go from cos 180 minus k? How did it become negative cos k? So cos 180, remember, now we decide, we look at our cast diagram, and 180 minus is in the second quadrant, okay, where only sine is positive, okay. So since only sine is positive in the second quadrant, cos would become negative, and then we write whatever angle we have left, which is k. So that's how it became negative cos k. So let's simplify it further. So now I can say negative cos k. I'm going to put them in brackets so they look nicer and neater. Now I have negative sine 90 minus k. So firstly, I notice that it's sine 90. So sine 90, even if you want, you can immediately just write a cos. Okay, but I just prefer to determine the numerical sign first. So you have to determine the numerical sign with the first trig ratio, which is sine. I draw my little cast diagram, and I can see that 90 minus all are positive, so it's definitely going to be positive, but there's already an existing negative there, so it's going to be like a negative times a positive, which is essentially a negative. It's going to change to cos k minus 1. Okay. Then we have tangent squared 180 plus k. So 180 plus is actually where tangent is positive, right? So when it comes to squared, it becomes tangent squared k. Positive because 180 plus is where tangent is positive. Okay, but you'll see we learned later that it does not matter what the reduction is, because it's squared, it's always going to be positive. The reduction of a squared trigonometric function cannot make it negative. We'll go through some rules later. And then I have again times cos k times cos k. So actually we haven't done identities, so I'm not going to take it further than this. I can simplify the top two. Cos k, negative cos k times negative cos k can actually be positive cos squared k minus 1 divided by, okay, I can simplify the bottom maybe. See, tangent squared k can be written as sine squared k, this involve identities, over cos squared k, okay, multiplied by cos squared k, because I'm multiplying these two, right? Cos squared k, I mean cos k times cos k gives me cos squared k. I can cancel this and cancel that. You see, one's in the numerator. Now this is obviously within the denominator. It's like having cos squared k over 1. They cancel. Okay, now I can simplify this. Cos squared k minus 1 over sine squared k. Okay, so for those of you who've done identities, which I'm guessing is most of you, you might know how to continue. For now, I'm not going to continue just because you and I have not done identities together. This can be simplified more, but we'll leave it for another time. For now, this is the simplest version that we can, that we're going to simplify that too. Okay, so I hope that makes sense. Right, again, please be wary of that minus 1. It's very tricky. You cannot cancel the whole time. Let's look at here in the denominator. Why was I able to cancel in the denominator? Because in the denominator, there was only multiplication. S and division, of course. S sine squared k over cos squared k times cos squared k of 1. No sort of subtracting or addition. Okay, so that's fine. Let us move on. Sorry, I didn't realize that these have identities. But before we move on, let us let's talk about squared trig ratios. So when we talk about trig ratios, we talk about sine, cos, and tan. When we talk about squared trig ratios, just like the example we did. So let's consider sine squared 180 plus theta. Okay, so firstly, it's a square. Okay, so remember, anything squared is always positive because you're going to put brackets. If I have 2 squared, this is 4. If I have negative 2 squared, this is also 4. Put it in your calculator and try it, because it's like you multiplying. Remember, this is essentially negative 2 times negative 2, and negative times a negative is actually a positive. Okay, so anything squared is always going to be positive. That's why the reduction angle, listen to my words carefully, I'm going to write it down. The reduction, okay, of a squared trigonometric ratio cannot make it negative. Okay, let us discuss, let us just in brackets write, what are we talking about when we say a squared trigonometric ratio? When we're talking about a squared trigonometric ratio, we talk about sine squared theta, cos squared theta, or tangent squared theta. Tangent squared x, the variable doesn't matter. Okay, that's what we're talking about. Cannot make it negative. Okay, so even though, right, if we consider the cast diagram, 180 plus is in the third quadrant, where sine is negative. Sine is negative in this quadrant. But because it's squared, this will simplify to positive sine theta, because it is squared. Okay, so I hope that makes sense. Now let's do another. If the negative already exists, okay, if it's negative cos squared 90 plus alpha. Okay, so firstly we know, okay, we're dealing with cos 90. All right, so let us determine something. Let us look at our cast. In cast, 90 plus, okay, 90 plus is what? 90 plus cos is negative, but you cannot get a negative from the reduction. You cannot. When it's squared, when you do reduction, even if it's in the negative quadrant, you cannot write a negative. Okay, I hope that makes sense. So therefore, this is going to be essentially, it's going to simplify to the negative that's already there, that's already there. You have to leave it. The negative, it's already there. This is the reduction of negative cos squared 90 plus alpha. So that negative is already there. It's multiplied by positive sine, because it's cos 90, positive sine squared alpha. So obviously this then simplifies to negative sine squared alpha. Okay, let's do one more example. If I have tan squared 180 minus beta. Okay, now if we consider our cast, 180 minus tangent's actually negative. Okay, in the second quadrant. But because it's squared, it will not, the reduction will not give it a negative. So this simplifies simply to just tan squared beta. Okay, I hope that makes some sort of sense. Let's move on. Okay, so we discussed reciprocals. Okay, we discussed special angles, which you need to know. Simplify the following without the use of a calculator. So let's do that, right? Tangent 60 is actually √3. So you write it. You say √3 directly because you should know it. So you can write it. Cot 30. Cot is the inverse of tangent. So this is 1 over tangent 30. This is equal to √3 plus 1 over tangent 30. Let's have a look at the value. Tangent 30. That is 1 over √3. So 1 over √3. Now remember, whenever you have 1 over something, you can simplify it by just flipping that fraction. So I'm going to flip this to get rid of the 1 over. So when I flip this, it becomes √3 over 1, which is basically √3 plus √3. And these are like terms, which becomes 2 times √3. Okay, hope that makes sense. Let's have a look at this. Okay. Sine squared 45 and cos squared 30. So 45, 30, these are special angles. We need to memorize their values. Okay, you don't need a calculator for it. So what you do is you find the value of sine 45 and you square it. You find the value of cos 30 and you square it. So the value of sine 45 is 1 over √2. 1 over √2. Okay, the value of cos 30 is √3 over 2. So I found each value and now I'm going to square. How do you square a fraction? Square the numerator, square the denominator. Square the numerator, square the denominator. I'm even going to write it in one more extra step. 1 squared, which is basically 1, √2 squared minus √3 squared over 2 squared is equal to 1 over 2 minus 3 over 4. This is equal to minus 1 over 4, I believe. Okay, let's move on. Right, Cartesian plane questions. Okay, so we're still getting to it. I can use a calculator because I examine also, you know. So you see the difference between using your calculator and not using your calculator is the fact that your calculator is going to give you a rationalized answer. If I was you, I'd just learn it. There are certain instances, you see, they don't expect you to like rationalize the denominator, so they want the answer unrationalized. So to be safe, I would just learn them. They're not, there's a quick way to remember them. What is the quick way? There's like a 1, 2, 3. It's fine. But yeah, if you put, for example, sine 45 in your calculator, you're going to get you're going to get √2 over 2, which is essentially the same thing. It's just rationalized. So you want to sub in the unrationalized value to be safe. Okay, technically you could argue that you rationalized it and that's how you got to it, but to be safe, I would just memorize it. Okay, so yeah, we'll get to identities. Maybe a lot of you are worried about identities and those are hard, but we have to perfect everything before we get there, right? So let's look at this Cartesian plane / Pythagorean question. So there's 2 different types of diagram questions you get. One is known as the in terms of questions, and the other is the Cartesian plane / Pythagoras questions. Now, how do you know when to draw which? The key fact is that in terms of questions, you will see the words in terms of. Okay, they want you to solve for something in terms of another variable. So that's a great hint that, okay, this is the in terms of question. And of course, I'll show you how to solve those. The Pythagoras questions, what's the hint to solving those? the hint is, okay, firstly, there's no in terms of, doesn't say in terms of. They give you like an interval. So sometimes they give you an interval, or sometimes they give you this, telling you that tangent theta is less than 0. Or sometimes they'll give you an interval. Is there an interval? Okay, yeah, obviously, yes, it's drawn. Okay, and then they'll either say without using a calculator, or they'll say by using a diagram. Generally not both. Okay, they can, however, give both. But a lot of the times they give one also. They don't have to give both. They say without using a calculator or with the aid of a diagram. Okay. Yes, and also the difference between this and this is, you see here, you know the angle normally. Okay. Whereas Pythag questions, the angle is an unknown. Okay, so that's another telltale sign of the difference. It will become obvious to you the more practice you have. So the first, let's follow the steps. The first is to isolate the trig ratio. So what does it mean to isolate the trig ratio? It means they're going to give you an equation like they do here. Okay, let's read the question. That would be a great start. If sine theta minus 2 is equal to 0 and tangent theta is less than 0, determine sine squared theta plus cos squared theta without using a calculator and by using a diagram. So to isolate your trig ratio, this is what we refer to as a trig ratio. It's your sine, cos, and tangent. The ratios because opposite of hypotenuse and blah, blah. Okay, so to isolate it, we have to get rid of what's attached to it. So firstly, I'm going to get rid of the 2. So 3 sine theta is equal to positive 2 when I take it over to the other side. Then I can divide both sides by 3. And I get that sine theta is equal to 2 over 3. So step 1 completed. I have isolated the trig ratio. Determine the quadrant. So we are going to indeed use a Cartesian plane, okay, or a diagram for this question. But where are we going to draw our diagram, in which quadrant, right? That's what we need to decide. So that's what we're going to decide now. Determine the quadrant, okay? So there's two indications, okay? There's two indications to which quadrant you're going to draw it in. The first indication is when you've isolated your trig ratio, the value that you get for sine, is it positive or is it negative? And thereafter, you'll solve accordingly. So sine, okay, is positive because it's positive 2 over 3. Sometimes you get a negative, then you'll deal with it accordingly again, right? So because it's positive, okay, we ask ourselves, in which quadrant is sine positive? Sine is positive in the first quadrant and in the second quadrant. Okay, so these are our options now. But now, which one do we draw it in? Do we draw it in the first or do we draw it in the second? We need a definite answer. So these gives us two options, and then to eliminate one of them, we can use the other information given. Now, a lot of the times, like I said, this is given as an interval. So they tell you theta is between 180 and 60, whatever, and then you can determine which intervals fall in there. But now they say also that tangent theta is negative. So tangent theta is negative in which quadrant? Tangent theta is negative in quadrant 2 and quadrant 4. So this indicates to us that it needs to be drawn in quadrant 2 and quadrant 4. Or. Okay, so the one that's common between the two is quadrant 2. So this sort of gives you an idea, and then this gives you the definite one after eliminating the other one now. Okay, we will go through maybe one more example because that can be confusing. So therefore, we're going to draw in the second quadrant, which is here. Now, before we get to anything, I'm going to teach you how to draw your diagram. So you always start from origin, second quadrant, so it's here. You draw a diagonal line, okay, to form part of your triangle. Then you always complete the triangle to the x-axis, whether it's up or whether it's down. So even if we were drawing in the third, we'd finish there. Even if we were drawing in the fourth, we'd finish up to the x-axis. Even if we were finishing in the first, down to the x-axis, always x-axis. Okay, so I drew it in my second quadrant. First of all, an information given. This is my x-axis. Okay. So Cartesian plane, okay, second quadrant, you draw your diagonal line and bring it down to the x-axis to complete it. Now we actually have the value for sine theta. Sine theta is equal to 2 over 3. Now sine is also equal to opposite over hypotenuse. Opposite is the issue with this question. Give me 1 second. Okay, fine. Okay, let's just continue. Okay, so 2 over 3 positive 2 over 3, so it's positive in first and second. First and second of the 3. Density that is negative, and that is negative in the second and fourth. Okay, so we drew it in the second. That's fine up until now. Okay, so yes, like I was saying, tangent theta is 2 over 3. It's actually opposite of hypotenuse. So we have the value of our opposite. We have the value of our hypotenuse. So we always consider theta as the angle. Sometimes I'll consider it up until here, or I'll consider it up until here. Don't mind it, don't overthink it. Just understand that it's the part of the triangle that's basically part of that angle. Okay, so we're working, this is our theta and the triangle, this angle here, this corner, not that one, not that one, always the one that's part of this angle already. Okay, so that's our theta. So we know the value of our opposite, it's 2, and the value of our hypotenuse is 3. Okay, so we're using SOHCAHTOA. Yes, correct. Sorry, we not go through SOHCAHTOA as yet. We did, I think. But yes, correct. We are using SOHCAHTOA to understand that it's opposite of hypotenuse. Thanks for that. Sine, okay, is opposite of hypotenuse. Cos is adjacent over hypotenuse. Tan is opposite over adjacent. So SOHCAHTOA. Sino, cosa, tanoa. Okay, whatever. So yes, indeed we are using that, the fact that sine is opposite of a hypotenuse, SOHCAHTOA. And now we can fill in the values because like I said, that is the theta we're working with. So its opposite is 2. How do I know? Because I know. Its hypotenuse is 3. How do I know? Because I know it from rearranging the equation. Okay. Now, how do I find the third side? Someone tell me. How do I find the value of the third side? Sorry, excuse me. Theorem of Pythagoras theorem, that is indeed correct. So what you're going to do is, remember, this is the hypotenuse, this is the adjacent, this is the opposite with reference to theta, which is there. So the equation is always hypotenuse squared is equal to adjacent squared plus opposite squared. So you're actually going to subtract them because we have the hypotenuse. We want to leave the adjacent alone. In order to leave the adjacent alone, we basically take the opposite over to the other side and subtract it. So that's exactly what we're going to do. Minus the opposite squared. Then we can square root it even. So adjacent, and I'm going to substitute values now. Square root. Hypotenuse was given as 3. 3 squared minus opposite is 2 squared. So we get the adjacent as 9 minus 4 is 5. So we just get it as square root 5. Square root 3 squared minus 2 squared is indeed square root 5. So the adjacent value is square root 5, or is it? Is that correct? Is it square root 5? Is the correct answer square root 5? Do you guys agree with that? No, yes, maybe. Okay, technically yes, very good, minus. So technically the length is correct, square root 5, but it should be negative square root 5 because at the end of the day, we're dealing with a Cartesian plane. Okay, so we have x and y axes, okay, and remember in a Cartesian plane, you have positive and negative. So because these are like x values, because this distance from here to here represents an x value distance of negative 5. That's why we get negative 5. Okay, so just be careful. Remember, this is positive too because it's up, and then the hypotenuse is always positive. Okay, so let's try and finish up. Just sorry for those of you who need to leave. You can watch this afterwards. For those of you who want to stay, I'm just going to finish this question, and we can end it there. Okay, so now we have an entire triangle filled in, completed in the correct segment, right, in the correct quadrant, sorry, with the correct sign, negative. That's supposed to be positive. That's always positive. Now we can determine what they want us to determine. So they want us to determine sine squared theta plus cos squared theta. So that's actually easier than it thinks, because easier than you think, because where do we get sine theta from? We get that from here. Sine is opposite over hypotenuse. So sine is 2 over 3. Cos is negative 5 over 3, negative root 5 over 3. And then we squared. So sine is, we said, 2 over 3 squared plus cos. Cos is adjacent, so negative square root 5 over 3 squared. Okay, so now we square the top, square the bottom. So I'm going to do that. 2 squared over 3 squared plus negative 5 over 3 both squared. And this is going to simplify to 4 over 9 plus 5. Okay, over 9, which is going to simplify to 9 over 9, which is going to simplify to 1. Okay, and that's our answer. So yes, this is how we do a Pythagoras question. We'll do one more and next week, just because I want to clarify how to determine the quadrants one more time. Okay, but essentially, yes, that is how we drop our Cartesian plane. It's quite simple, right? And then your trig ratio you get from that, whatever value you have there, input it into the triangle, always get the third side, and then solve the question I want you to solve. You're getting all your values from the diagram. Okay, cool, perfect. Thank you guys so much for joining. I will see you guys next week, okay, where we will continue trigonometry. Probably not finish, but at least continue it, and we're getting there. All right, good luck. Have a good week of school. For those of you who are still writing, all the best. Don't fail. That's not ideal at any point in time. And yeah, cool. I'll see you guys next week, same time, same place. Thank you guys so much. No problem. Jazakallah khair. Assalamu alaikum.